Okay, the second assessment over graphing linear equations. Okay, so you have to take the equation and graph the equation. So 6x minus 2y equals 12. Now I can clearly see that this is in standard form. Okay, so standard form. So if it's in standard form, because the x and the y are on the, if you want to make that plus negative, the x and the y are being added together, okay? And there's a constant on the other side. So standard form we use by finding the x and y intercepts of the equation. So that is when I only need 2 points with 0 inserted for x and then 0 inserted for y. So then I write the equation down twice. So 6 times x plus negative 2 times y equals 12. And then a second time, just write it. So x is 0. Well, if x is 0, 6 times x, 6 times 0 would be 0. So I end up with negative 2 times y equals 12. Well, I undo the multiplication by dividing by negative 2. And that gives me negative 6. Okay, the y is 0. I can eliminate the negative 2y because having a negative 2 times 0 is 0 because the y is 0. So 6 multiplied by x equals 12. So I can divide both sides then by 6. And 12 divided by 6 is 2. Okay, so these are 2 coordinates. And this is the x, the sideways, and this is the y up and down. So the x is 0, so I don't move sideways, but I do go down 6. So 1, 2, 3, 4, 5, 6. Okay. You can label that point. You don't have to. 0, negative 6. Then 2, 0. So I go sideways to 2, and then I don't move up or down at all. Okay. And that's my x-intercept of 2, 0. Okay, then I take my ruler and make the line all the way across. Now there is a domain limit on this. This is not going to end up being a continuous graph. Okay, so remember how to do this. So you've got 2 as your critical number on the x-axis. So on the x I go to 2, and I don't really have to move it. The point's right here. Now, this is my right, this is my left. This is my right, this is my left. The right is always greater than, because that has all the x values greater than 2. And then to the left is all the x coordinate values less than 2. Okay, so what do we have here? What sign do we have? It looks like we have the less than sign. So if I have less than, I want to keep the left part, the less than part. I need to keep that. And I need to eliminate the greater than from the graph. Okay, so it's like a ray. Okay, all this has x coordinates less than 2. Okay, it does. Now the range you don't need to worry about. If you had to, well, here's your point. You're at 0, so 0 is your critical value, and from there I move down, so it'd be y is less than or equal to 0. But don't worry about that. Okay, now my next equation, here the y and the x are on opposite sides, y here and x here. So that's in slope-intercept form. Okay, so to graph the line, I need to do the slope and the y-intercept. Now remember, the slope is the letter m and the y-intercept's the letter b. So we have our m here, and we have our b here. So my m is negative 1/4, and that's exactly how I want it. I want it in fraction form. Okay, now the y-intercept's like your beginning point, okay? You have positive 2. So 2, put a comma, 0 in front. So 0, 2, that means I don't move sideways at all. I go up to 2. So that's where 0, 2 is at. Okay, then to get my subsequent points, I use my slope. I will be, from the beginning, from this point here, I'm going to move down 1 unit, and every time I do that, I move right 4 units. Don't ever move left, okay? So I go down 1, right 1, 2, 3, 4. There's my next point. Down 1, right 1, 2, 3, 4. Okay, and then you can't do it again or you run off the graph. So I take my ruler then and connect the points. Okay, we start with it as a continuous graph, but we know it's not because the domain restriction is that x can be greater than, or has to be greater than or equal to 2. So I go to 2 on the x-axis, and I go straight up and make a point on my line, circle it. Okay, once again, this is the right, this is the left. The right has all x greater than, the left has all x less. So what sign do I have? Well, it looks to me like I have a greater than sign, so I need the greater than part. I don't want the less than part. We need to get rid of that. Okay, so every coordinate here has an x value greater than 2. Now the y, you look up here, and it looks to me like the y is about, it'd be like 1.5 would be the critical number, and it goes down from there, so y would be less than or equal to 1.5 for the range in the function. Okay, now here x equals 2. So there's no y. It's a single variable. It's not in standard form or slope-intercept form. It's just a single variable. Okay, so if it's a single variable, what variable is that variable? It's x. So x is 2. So the 2's go in for the x's. And the y, I can do that as many times as I want. 3 is probably enough, though. And the y is whatever I want to pick, so that would be 1, 2, 3. Okay? So that's x, that's y. So I go right 2, up 1. I go right 2, up 2. I go right 2, up 3, and that's my line. It's straight horizontal, so it is continuous. Okay? Okay, the next problem, y equals 2x minus 1. So that, again, is in slope-intercept form because we have the y by itself and then x over here with an operation of multiplying by 2 and having a negative 1 added to it. So again, we'll go with the slope and the y-intercept. So the slope is 2. Now, anytime the slope is an integer, we need to make it a fraction by putting over 1, especially if I have to graph it. Then my y-intercept is negative 1, and of course that occurs when x is 0. Okay? Because x is 0, 2x is gone, and y equals negative 1. So I stay in the middle, I go down 1. Then from there I use my slope. I go up, 2's positive, so we go up this time and 1 to the right. So I would go up 2, right 1, up 2, right 1. You can do it a bunch of different times. So I'm going to start with my line, and it's continuous to start with. But it does not stay continuous. It becomes a discrete graph because negative 1 is here, so I go down, make a point on my line. Then I also have positive 1, which I go to, and I go up. There's already a point there, so I just circle it. Now, I only want the points. This little concoction means I only want the points that are between, that have x-coordinates between negative 1 and 1. And no, 0 is not the only one, because you could have negative half, positive half, a bunch of different things. So we can then eliminate this and then eliminate the other side. Because remember, all those coordinates go outside the boundary. Okay, tell whether the point negative 6, 5 is on the line 3x plus 5y equals 7. So we have 3 times x plus 5 times y equals 7. So we need to replace both the x and y variable. So if this is on the line, if that's in standard form, if I graphed it, would negative 5, 6, 6, 5 be one of the coordinates on the line? Well, it all depends on if when replaced with variables, whether it equals 7 or not. We're about to find out. So I have 3 times parentheses plus 5 times parentheses equals 7. Okay, so x we're going to put negative 6 in, and then for y we're going to put our 5 in. Okay, so we have 2 multiplications we have to figure out. 3 times negative 6 and 5 times 5. Well, 3 times negative 6 is negative 18, and then the plus operator, and then 5 times 5 is 25. Now, does that equal 7? Well, really only one way to find out. I mean, you could think of it as a number line, but I think it does. Okay, so 7 is equal to 7, so that's yes. Yes, the point is on the line. Okay, that line does run through that coordinate point. Okay, calculate the slope of the line with the given points. When x is negative 3, y is 5. But when x is negative 6, y is 13. And all you're being asked to do is find the slope. You do not have to write the equation. Okay. So we know the slope is y minus y divided by x minus x. So my y's are 5 and 13. You can go 13 minus 5 or 5 minus 13. I'll do 13 minus 5. Now if I take that road, I go negative 6 minus and then negative 3. But if I'm subtracting a negative, it's plus plus. So that gives me a difference of 8. And negative 6 plus 3 gives me a difference of negative 3. Okay, so if we have a negative first off on bottom, you need to move it to the top. If they're both negative, the negatives just go away. And then I do the ABC. So negative 8, ABC 3. Okay, I got a mixed number, which is never good for slopes. So I go second, ABC equals, and I still have negative 8 over 3. Okay, so M equals negative 8 thirds. Okay, and then the last problem. A bank account is losing money at a constant rate of amount each month. After 2 months, the account has $300. After 4 months, the account is down to $230. Find the average rate of change of the account in dollars per month. So down here, all I need to figure out is the dollars per month. That's really easy. That's just taking the dollars divided by the months. Well, here's the problem. We have 2 different combinations of dollars and months. So if I take $300 divided by 2 months, that's $150. Now, then if I take $230 divided by 4, $230 divided by 4 months, that's $57.50. So those do not match up. So we need to use, since we had 2 combinations, I use my y minus y divided by x minus x formula. Okay, so remember, times the x, so months, and then y is the money. So in the numerator, we have to take our money amount. So I'd be taking 300 minus 230. Okay, then for the months, well, with $300, we had 2 months, so that would be 2 and then minus 4. So that equals $150, because that's what $300 minus, or no, I'm about wrong. That's $70. And then 2 minus 4 is negative 2. So it's $70 divided by negative 2 months. And I got negative 35. So the dollars per month is negative 35.